Okay, so like I said, we are going to be working with the rotation of conics. Okay, so all the conics we have seen have looked somewhat like this. But the x squared or y squared could have been missing if it was a parabola. Otherwise, we've seen x squared terms, y squared terms, x terms, y terms, and constants. Okay? Now, if we have this xy term thrown in there, then we know that it is a rotation of a conic. Unfortunately, it is not as simple as looking to see if there's an x squared and a y squared to determine if it is a hyperbola versus ellipse versus parabola. All right. When the xy term is thrown in there and it is a rotation, we have a different way of determining the type of conic we have. Okay. So what's going to happen is eventually we're going to have to find this angle of rotation, which is why we did those few problems on the board this morning. Okay, we're going to have to find this rotation so we know how far to rotate our conic. All right, so let's first talk about how do we identify the type of conic. All right. We're going to look at what we call the discriminant. You may recognize b squared minus 4ac. Where do we see that? In the quadratic formula, okay? So, you already know b squared minus 4ac. Remember it again, okay? Now, what are b, a, and c? What are those? Let's go back to here. A is the coefficient of x squared, b is the coefficient of xy, c is the coefficient of y squared. If you need to remember that, you may want to write it down. So taking b squared minus 4ac, you are going to compare it to 0, and that will tell you what type of conic you have, whether it's rotated or not. Okay. So if your discriminant is negative, you're going to have an ellipse or circle. If it's a rotation, we do not know which one, so you have to actually write ellipse or circle. All right. If it is not a rotation, then we know the difference. If your discriminant is 0, it is a parabola. If your discriminant is positive, you have a hyperbola. Okay. It will be important to identify the type of conic you have before you actually go to work the algebra. All right. That way you know what kind of standard form you need. Okay. So let's practice. My first example, 2x squared minus 3xy plus 2y squared minus 2x equals 0. Okay. So our discriminant, b squared minus 4ac, what is b? Negative 3, so b squared minus 4 times what's a? 2. And what's c? 2. What is that? Negative 7. Okay? Even if you can tell that it's going to be negative, does it really matter the value? No. This is less than 0, so we know that it is going to be either an ellipse or a circle. You have to write ellipse or circle. And with a rotation, we can't tell yet. Okay. Next one, we have x squared minus 6xy plus 9y squared minus 2y plus 1 equals 0. All that matters are the a, b, and c. All right, so b squared minus 4ac. What is b? Minus 4 times what is a times what is c. 36 minus 36, right? So this is a parabola. In my last example here, 3x squared plus 8xy plus 4y squared minus 7. What is b? So b squared minus 4 times a times c. 64 minus 16 times 3. Okay, so 64 minus 48 is positive, right? Which means we have, not everybody all at once. Okay, it will be important for us to identify what we have before we do the algebra. Now, let's talk about the algebra. Okay. With this xy term, we can't separate our variables like we were used to doing and completing the square, because that one term has both an x and a y, and we can't split it apart. So instead what we're going to have to do is we're going to have to rewrite our equation based on our rotation. All right? So, here, okay. So what we're going to do, we're going to take this general equation, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Well, and we are going to eliminate the xy term. So we're going to rewrite it in terms of x primes and y primes, okay, so that the xy term is gone and we're back to something that looks more familiar to us. Okay. How are we going to do that? Okay. The first thing we need is our rotation, okay, for our axis. We're basically going to take the xy axis and we're going to rotate it. All right. So to determine our angle of rotation, we're going to use one of these. Okay. We are going to always move counterclockwise. All right. But you can either take the cotangent of 2 theta equals a minus c over b, or you can use the inverse. The tangent of 2 theta is b over a minus c, whichever is more comfortable to you. You are probably more comfortable with tangent, so if you want to use the tangent, that is perfectly fine. Okay. How are we going to get these x primes and y primes? We're going to make some substitutions. Okay, so we're going to take our general equation up here with that pesky xy term, and we're going to substitute for x and y. Okay. So x will become x prime times the cosine of our angle minus y prime times the sine of our angle. Y will become x prime times the sine of theta plus y prime times the cosine of theta. You will need to remember these substitutions. These will be important. we're going to have to identify what kind of conic it is. We are going to have to identify our angle of rotation. We're going to identify our x and y substitutions, and then what we're going to do is we're going to plug these binomials in for x and y. From there, everything is going to be in terms of x prime and y prime. We're going to have to go ahead and do some multiplication and combining like terms, so then we can put something that's kind of messy into standard form. Okay. This is algebra intensive. You will need to be very, very careful with your algebra. Okay? This is not something you want to rush through. This is something you want to be very meticulous with. Okay? Just a warning. Don't want to scare you. I just want to warn you. Now, you notice we have some trig involved here. We're going to have to identify an angle and use that angle with sine and cosine. So what's going to be important? Your unit circle. Now, luckily, trig was not that long ago, right? It should be fairly fresh in your head. But what we can do, very briefly, is review the first quadrant of our unit circle. Okay? We know the first quadrant, we know them all, right? Okay. Has everyone written down what they need? So, first quadrant. What point is this? What? How about 1, 0? What point is this? 0, 1. So at 0 and pi over 2. At pi over 3, at pi over 6, excuse me. What's our coordinate? At pi over 4. And pi over 6, pi over 3. Hey, x represents which trig function? The cosine of that angle. Y is the sine of that angle. Tangent we find by taking y over x. Beautiful. First example. You'll want a lot of room, so if you're at the end of the page, flip to the next one. All right. First thing we need to do is identify what type of conic this is. So we need to look at the discriminant. So b squared minus 4ac. Greater, equal, or less than 0. It's going to be a negative number. Okay, which means what? All right, we like those, right? Yeah. All right, now we need our angle. Okay, do you prefer to use cotangent or tangent? Tangent. So the tangent of 2 theta is, what did we say? B over A minus C. So the tangent of 2 theta is, that simplifies down to radical 3. Because this would be a negative 6 in the denominator. Okay. Where is the tangent? Radical 3. That's convenient. Pi over 3, which means 2 theta is pi over 3, correct? Which means what is our angle? Okay. We have two things checked off the list. Now we need our substitutions. Okay. X will become x prime times the cosine of our angle minus y prime times the sine of our angle. What is the cosine of pi over 6? Very good. So radical 3 over 2 x prime minus, what is the sine of pi over 6? So minus 1/2 y prime. There's our x substitution. I'm going to go ahead and box it just so we can pick it out easily later. Okay. Our y substitution, y becomes x prime sine of theta plus y prime cosine of theta. So this becomes the sine of pi over 6 we decided was 1/2. So 1/2 x prime plus radical 3 over 2 y prime. I'll box it just so it's easy to pick out later. So this was all just our setup. Now we actually have to make this substitution so we know, so we can eliminate the xy term. Okay. Are you ready? So 7x squared becomes 7 times radical 3 over 2 x prime minus 1/2 y prime squared. Minus 6 radical 3 times xy. So x is this binomial, y is this binomial. Plus 13y squared minus 16 equals 0. We replaced all of our x's, all of our y's with those binomials. Okay. Do you see why I said we're going to have to be careful with our algebra? Okay. We have a lot of binomials to multiply together. It's going to be okay, because then we're going to have like terms we can combine. And by the end, this will be beautiful. Right now, it doesn't look that way, but by the end, it will be. Okay, so let's start here. We have 7 times. We have radical 3 over 2 x prime minus 1/2 y prime, the quantity squared. So we have binomial times binomial. We know how to do this, right? Okay, we take the first times the first, which would be what? Three over 4 x prime squared. Right? First, so now we have the outside. That's going to be our last. So we have to take, right, because this is binomial times binomial, right? If you need to write it down, right, we have okay, if you need to write it out like that, you can. What's our outside term going to be? Yeah, we're FOILing. So outside. So that negative radical 3 over 4 xy, right? Inside term. Same thing, so can I just double this? Yes. And then our last term. 1/4 y prime squared. Okay. Minus 6 radical 3 times, okay, these two binomials multiplied. So our first is what? Radical 3 over 4 x prime squared, right? Outside? What? It should be 3/4 xy, correct? What? Inside terms? Negative 1/4 xy, and then our last. Negative radical 3 over 4 y prime squared. You have a question? It's supposed to be a radical 3 because it's radical 3 over 2 times 1. All right. I don't have enough room, so I'm going to continue here. Okay, I have to write big so you can see. You guys have plenty of room on your paper, hopefully. Now we have this binomial squared. Right, so if you need to write it out, you can, hopefully by now. You're good enough at working with binomials that you don't necessarily need to, but if you need to, there's nothing wrong with it. So what's our first? It's your 1/4 x prime squared. Outside. Radical 3 over 4 xy. Our inside? Same thing, right? So I'm going to double it. And then our last would be 3/4 y prime squared. Minus 16 equals 0. Okay. Here's where we need to be very careful. All right, well, we needed to be careful in that step too. Now, we have all of these with coefficients. So we're going to need to distribute those coefficients through so that we can combine like terms. By the end of it, which variable needs to be gone? XY needs to be gone. If XY does not disappear, you've done something wrong. Okay? So, let's do this. We're going to distribute the 7 through. This becomes 21/4 x prime squared. Minus, this becomes you want 14 radical 3 over 4? When you simplify it, what do you want it to be? 7 radical 3 over 2, right?
Yeah.
Plus 7/4 y prime squared. Minus, what does that become? Okay, now I know that I could simplify 18/4, but look, x squared over here has a denominator of 4, so I'm just going to keep it as a denominator of 4. Is that okay with everyone? Okay? This becomes what? 18 radical 3 over 4 xy. What does this become? Plus 6 radical 3 over 4 xy. And then last, we have positive 18 fourths y squared. Almost there. I'm going to go to the next line again. Plus 13 fourths x prime squared plus, what does this become? And then 13 times 3 over 4 would be minus 16 equals 0. Okay, so the first thing I would look at are your xy's. Do they cancel out? I'm going to go back and I'm going to change this to 14 fourths since everything else has a denominator of 4. Okay. I had a radical 3 though, didn't it? Okay. So, negative 14 radical 3 over 4 minus 18 radical 3 over 4 plus 6 radical 3 over 4 plus 26 radical 3 over 4. Is that 0? So let's work with the numerators. Negative 14 minus 18 plus 6 plus 26. Is that 0? Then those are gone. Yay! That's exciting, right? All right, let's combine our x squareds. We have 21 fourths minus 18 fourths plus 13 fourths four. Okay. Our y squared, 7 fourths plus 18 fourths plus 39 fourths. 64 fourths. So that would be 16. And we don't have any x's, we don't have any y's, which kind of makes it nice, right? Okay, now, here's our new equation. Okay, everyone can take a little bit of a deep breath, right? Okay, we made it. We're not done yet, but we made it. Okay, remember, we're working on a rotation of pi over 6. So this is the equation for our pi over 6 axis, okay? What we need to do with this, though, is put it into standard form so that tomorrow we could graph this on a rotated axis, okay? So this is an ellipse. Let's put it in standard form. What do we need to do? Okay, I heard some complete the square. Do we need to complete the square? Okay, we do not need to complete the square because we don't have any x's or y terms. We just have x squared, y squared, and constant. So all we're going to have to do is move this constant over and then divide by 16. So we have x prime squared over 4 plus y prime squared over 16 equals 1. So this is our standard form equation for our ellipse on a rotated axis. So tomorrow, yes?
Would it be y prime squared
Oh, yes, that's what I meant. I'm sorry. Thank you. So tomorrow, we'll graph this on a rotated axis. Okay? Keep in mind this is x prime and y prime. So it's not like the xy coordinates that we're used to. We're going to do this on a rotated axis. Okay. Whew. Questions? Yes. On a test? Probably only one. But it's going to be worth a lot of points. Okay? Your homework tonight, you're not going to have very many. Okay? Now, or do one more. Look at it. Look at it. I did the hard one first. You're welcome.
I think I just give up. I'm like, oh.
All right. Discriminant.
Yeah, okay.
B squared minus 4AC. What's our B? 1. What's A? What's C? Huh. So what is this? Hyperbola. Okay. Let's talk about our angle. Our angle is next. The tangent of 2 theta is going to be, we decided, B over A minus C. Okay. Dividing by 0, is that okay? No, so that is an undefined. Where is the tangent undefined? Yeah, 90 degrees, right? Okay, so our angle of 2 theta would be pi over 2, which means our angle is, oh, that's a nice angle, isn't it? Yeah. Okay, now what's next? What? Are we okay? What do we do with our angle? Okay, we need our substitutions, right? What's our x substitution?
X equals x prime equals cosine minus y. That's what the line is.
Oh, I thought you said one. Hey, what's the cosine and the sine of pi over 4? Huh?
Or yell yourself.
Okay. Now we'll do y. What's that substitution? Right. X prime sine plus y prime cosine. Okay, so you notice x has subtraction, y has addition, cosine sine, then sine cosine. You need help remembering it. So y is radical 2 over 2 x prime plus radical 2 over 2 y prime. Hey, when we make our substitutions, we only have x times y minus 1 equals 0. Is there a lot going on? No, there's not a lot going on, so do not panic. X times y equals 0, so we have x times y minus 1 equals 0. We only have one FOIL to do. Okay? What's our first product? 2/4 x prime squared. Our outside product. 2/4 xy. Our inside product. Oh. And our last. Do our xy terms cancel out? Good, that means we did our algebra correctly. And we have 1/2 x squared minus 1/2 y squared equals 1. And our hyperbola is already in standard form, isn't it? Okay. Now, I know that these problems take some work. You only have 4 problems that are the algebra. Okay? Do not graph them. That is what we are going to save for tomorrow. Okay? Anything else should be just identifying what type of conic it is. Okay? Do not graph any of these. You understand? Okay? What I want you to do is go ahead and get started on these. We have some time. Now, tomorrow is going to rely on you looking at these problems and attempting these problems tonight. So you need to come in for tomorrow with some attempts on all of the algebra ones. Okay? So that we can discuss where we made mistakes, and then we can discuss how to actually graph these. If you don't do the algebra, you can't do the graph. All right?